Guys, remember, whatever we get through is not homework. Okay, let's go. We're doing practice test 3. Question number 1. Okay, everybody's on practice test 3. Right, guys? Please go to my practice test. Okay? Find the domain for the last time. I got it. For the last time, what is, or what are, the things I have to worry about with domain? Whatever is under the radical is greater than or equal to 0. Thank you, Erica. And the other one is? The denominator cannot equal 0. There we go. So when I look at problem number 1, right off the bat, I have both. Whatever is under the radical is greater than or equal to 0, so x is greater than or equal to 4. Whatever is in the denominator cannot be 0, x cannot be 6. Two-part answer. Two things written in the answer blank. This and this. Got it? Next problem, B. What's the answer? Jordan. All reals. And the reason the answer is all reals is what, Jordan? Exactly. You don't have either one of these, so it's just all reals and you move on. Next problem. I got a radical, don't I, Zach Bond?
Yeah.
What's the rule for radicals?
Greater than or equal to?
Whatever is under it is greater than or equal to 0, so my domain is everything greater than or equal to -5. D, what have I got? A denominator. What do I know about denominators? Whatever's in them can't be 0, so x cannot be -7. Erica?
What do you do if the radical's in the bottom?
Then it would be, instead of greater than or equal, it would be just greater than, because you would be combining both of those. The denominator can't be 0, and what's under the radical has to be greater than. Number 2, find the horizontal and vertical asymptotes as well as the holes. All right, so our first one looks like this. Any thoughts? No holes. And you want to factor the bottom? Okay, I think that's a good idea. It's a great idea. How does the bottom factor?
X plus 1, x minus 3. I mean minus 4.
Plus 1 minus 4? How do we know there's no holes? There's no canceling. All right, how about asymptotes?
The horizontal asymptote is 0.
Y equals 0. I want to say one more time, when you list those asymptotes, you got to say y equals or x equals, right? If you just put the number, it's -half. Why is that asymptote at 0? Because there's more x's in the denominator. That's right, you got more x's in the denominator. All right, how about vertical asymptote? There's 2 of them. Where are they?
-1 and
X plus.
X equals -1.
And x equals -4.
And x equals +4. There's 2 vertical asymptotes because there's 2 numbers that would make that 0. the next one? How you gonna start this? John Brokaw.
Factor.
Yeah, I think you're right. Do you know how to factor that, John? Watch those signs. Or you're the numerator, right? Watch those signs. Everything's positive. So it's going to have to be plus and plus. And let's see, it's a 6. 2 and 3. And how about the bottom, John?
Minus 5 plus 3.
Perfect. Uh-oh. All excited, because what happens? We can cancel. So here's our new problem right here. That's our new problem. And because we had a cancellation, we know we're going to have a hole. Anna, where's that hole going to be? Okay. The hole, remember, is at the opposite of what canceled? Negative 3. One more time. The hole is at the opposite of the thing that canceled out. So since x plus 3 canceled out, we're going to have a hole at negative 3. Got it? But the hole has another coordinate. Where is that going to come from? Plugging it back in. So if I plug in negative 3, what do I get? Negative 1 over, which is 1/8. So that's where your hole is. Now, vertical and horizontal asymptotes. Look right here. Where's your vertical?
5.
X equals 5. From the denominator. Where's your horizontal? Y equals 1. X over X. Or X squared over X squared in the original.
Why do you use the second problem to find the asymptotes?
Well, because part of that's going to cancel out. So you have to use the second one for the vertical. You could have used the first equation for the horizontal. I always just use my reduced problem for everything, but I never get it wrong. And finally, the last one. How do you want to start this? You want a factor?
Yeah.
Everything factors, right? Pretty easily. Connor, how's that numerator factor?
X minus 4, X plus 4.
Perfect. And Katie, how's the bottom factor?
+1.
Perfect. Now I did all that factoring and nothing canceled, which simply means that we are not going to have any holes. Vertical asymptotes, I don't know whose phone or iPad that was, but we need to make sure it's off. Vertical asymptotes, where are they? 2 of them again, right?
Yeah.
Why are there 2 vertical asymptotes?
Two.
X equals 1, X equals negative 1, right? How about horizontal?
Y equals 1.
Y equals 1, perfect. Anybody have a question about that? Okay, ready for part 3? This is the graphing part. And right off the bat, the very first one is our piecewise. right, so here we go. You do not have to do this, but the first thing I'm going to do is fold my paper right there, put a crease right there. That's where my piecewise function is broken into pieces. This is the break line. How do I know that? Right here. So I know when I get around, remember the dots we always have on these things? The dots are going to be on that line. I'm going to forget all that for a minute, and I'm just going to graph that. What does that look like? That's a parabola. So I'm just going to sketch in my parabola. Everybody okay? Now, that parabola crosses my line right here. So I'm going to put a dot there. And that dot is going to be colored in. Would you agree with me?
Yep.
Did somebody say why? Savannah?
Why don't you down to?
For this equation?
Yeah.
Okay, it doesn't say x squared minus 2. It just says x squared. Right, down 2 would be x squared minus 2. This is just my plain BFF right here. Now, I have to erase part of this parabola. I want to keep the part where x is greater than, Zach?
Why'd you color it in?
Because it's an or equal to in the statement. Now I'm going to erase this part. Is everybody okay with that?
Yeah.
So this is the first piece of the picture. Now I'm going to do the second piece. What shape is that? That's a line. Tell me about that line. It has a y-intercept at -1 and a slope of 1 over 1. So up 1 over 1, down 1 over 1. I'm going to go ahead and draw in that line. And that line crosses my dashed line right here, right? So I put a dot there. This dot is going to be open. And I am going to erase the right side of the picture. And there is the piecewise function. The two pieces are graphed. Katie?
So when it's open, don't have to go down.
No, 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 no. The direction of that tells me which way to go. Left. I keep left. Here, I keep right. Whichever way it's pointing, that's what you keep. Now, if you want, you can get rid of that dashed line. And now you can very clearly see the two pieces. You don't have to put the line in or take it out, whatever you're comfortable with. Okay? Now we've got B. Now, Savannah, this is a parabola. How do I know it's a parabola? It's squared, but it's been moved around. This one's been moved around. So tell me how it's been moved, Carter Mahoney. It's been moved right 1, up 2. Everybody good with that? So right 1, up 2, there's her parabola, done. That problem should take you about 2 seconds. Lydia, what's going on with the next one here? And it's a V. Yep, it's a V. And we're going left 1, up 1. Everybody good with that? Why? How do we know it's a V? Because it's absolute value. This tells me that's grouped with the X, so it's opposite. It's going to left 1, up 1. Ashley?
I think you just said it. You said when it's in the absolute value.
If it's in the parentheses or the absolute value, it's grouped with the X somehow. It's the opposite of what you think. Okay, now we have e to the x plus 2. All right, you are sunk if you do not remember what e to the x looks like. That's right, Jake Hill. E to the x looks like this. It crosses at 1. You may not have known that. I'll just give you that piece of information. It crosses at 1. Where's this one going to cross then? What are you doing plus 2? What's happening there? Move it up. So now it's going to come up and cross at 3.
So every time would you draw 2 lines? Like
No,
just
no.
that top one?
You don't have to draw the original. Now, there are sometimes kids where it helps me to draw the original. You never have to draw the original. If you do draw the original, then make sure you do the other one in colored pencil or something so I know which one I'm supposed to be grading. Or erase the original.
Every exponential function, the line crosses at 1?
It does.
Okay.
In the original, yeah. In this, it crosses at 1. So in the original, this was like the asymptote. Well, that's going to be moved up 1. So now your asymptote, or no, 2, I mean, that's moved up 2. So now your asymptote is up here at 2. Oh, this is a cosine, and these are the ones that sometimes mess us up if we're not careful. So I'm going to go ahead and draw my regular cosine curve. Now, what am I doing to this cosine curve? I'm dropping it down 2. So, where's that point going to be if I'm taking it down 2? It's going to be down here now.
What is the cosine?
1.
Always said something.
So, every point is getting dropped down 2. So the purple one is the answer. Got it? And the last one, oh, a little trickiness here. First of all, do you remember your shape? This is this shape. Now what's happened? What does this do? What does this right here do first? Moves it right to. And then what does the negative out in front of it do? Actually, it doesn't make it point that way. It actually flips it upside down. So the original looks like, all right, I shouldn't say the original. This is the original. This is if we move it over 2. And now I'm going to turn it upside down. Now, those of you that were talking about having a shape that looked like this, a negative will accomplish that, but a negative in a different place in the equation. The only negative we've studied so far is the negative out in front, and that always turns you upside down. So if you had a parabola with a negative in front of it, it would turn it over like this. So this is your final answer. Moved over 2 and flipped upside down. You okay? All right, now we've got our function section where we're doing all different kinds of things. So p is 2x squared and q is negative 3x plus 1. So the first question says p of x times q of x. What am I going to do? Go live, people, we have tests tomorrow. Yes.
2x squared times negative 3x plus
Yeah.
1.
You're just going to multiply. Very good. Thank you. You're just going to multiply 2x squared times negative 3x plus 1. Now it's a multiply. So we're going to distribute. Negative 6x cubed plus 2x squared. That's your answer.
My alarm clock, I'm sorry.
Why is your alarm clock going off at 9:12?
I think I snoozed it a while ago.
Okay. Q of P of X.
It would be, you put the x in for x, so it would be 2x squared.
So P of X is 2x squared. You're exactly right.
And then you'd multiply.
This is 2x squared. So then we're going to go back to our Q function, and we're going to put whatever's in the parentheses right in there. So, Lindsay, what did you say that would be?
You would say negative 3 times 2x squared plus 1.
That's it exactly. And then simplify. So negative 6x squared plus 1. We're simply taking the P function and plugging it into Q. Some of you look so bored. I better have a bunch of A's tomorrow. All right, P of 2. What do? I want P of 2. What will P of 2 be? I put 2 in for the x. 2 squared is 4 times 2 is 8. So P of 2 is 8. Remember, we do exponents first. So 2 squared times 2. Now I want Q of negative 1. Negative 3 times negative 1 plus 1. What is that? 4? So the answer to the problem is 12. P of Q of 0. Where do I start? Q of 0. If I put in a 0 for Q, what do I get? 1. P of 1 is 2. The answer to the question is 2. Number 5, find the implicit functions. Franny, what are you doing?
I was looking at the map.
Your BFFs?
Yeah.
Okay. Now, I'm finding the implicit functions. What does that mean? I gotta solve for y. So what shall I do? Subtract the x squared from the other side. Okay. Now I'll divide by negative 1. So y squared equals x squared minus 25. Now, some of you might have negative 25 plus x squared. That's the same thing. That's absolutely fine. Either order is fine. Now, what do? Take the square root of both sides. And notice there are 2 answer blanks, like there will be on the test. So y equals the square root of x squared minus 25 or y equals negative the square root of x squared minus 25. Are you going to simplify this in any way, shape, or form?
No.
No, or I will come after you.
So can we not just put the plus or minus?
Well, I do have two answer marks.
Well,
Now, what is this number 6 on here?
I don't know.
I don't know either, but we all better perk up and figure this out. Here we go. All right, let's talk about this for a minute. Look at this function right here. If you plug a number into that function, two things happen. Let's say, pick a number like 5. Okay, if you plug 5 in here, what's the first thing you do to it? Multiply by 3. And then you subtract 7. So there are two functions, or two operations that happen. You multiply by 3 and you subtract 7. This says take any number, times it by 3, take any number, subtract 7. That's what happens in this problem. You multiply by 3, you subtract 7. Now, the order is important, right? Which has to come first? Multiply by 3. Okay, no question about that. Look at this setup. Which function, if you were going to do this problem right here, just this, where would you start?
at the end of it.
The n. So n has to be the 3x. The n function has to be the thing that you do first. Well, then what's your m function going to be? X minus 7. Got to have an x in there. And that's the answer. That's all there is to it. Let's try another one. You got some room, right? Let's try another one. Let's say p of q of x
What is this?
is x plus 1 over 6. All right? All right, so think about this function. If you put a number in, what are the two things that happen if you put a number in here? You're going to add 1 and then divide by 6. Quit throwing things, Erica.
Sorry.
We're going to add 1 and divide by 6. In that order. So now look at the setup of the problem. Which function comes first? Q, right? So Q has to be the function that adds 1. And then P will be the function that divides by 6. I think you got room for one more. Let's do one more. All right, here we go. Look at the function. What are the two operations that have to happen in this problem? 7x and x minus 11. You got to times x by 7. You got to subtract 11 from x. Everybody see that? We're multiplying by 7, subtracting 11. And when I say multiplying by 7, that means 7x. When I say subtracting 11, that means x minus 11. Always x. Now look at this part of the problem. This tells you what order these have to happen in. A of b of x. Which function starts the problem? B. Right? So b has to be 7x. Because that's the first thing that has to happen. And then A would be x minus 11. You getting the hang of that?
It's always the top.
All right. So we've got, I forget how much time. We have a little bit of time. Of everything I'm going to test you over tomorrow, we just practiced it all. What confuses you the most? And let's practice one of those problems, and then we'll be done for the day. Taylor. Finding the implicit functions. All right, let's do a problem where we're finding the implicit functions. Okay, last problem of the day, guys. Come on, hang with me here. Last problem of the day. It would be great if everyone passed this test. Let's set our goal. All right, so implicit functions. Here we go. Step 1. Subtract 2x squared. Now, some of you are going to write 10 minus 2x squared, and that's absolutely fine. Just move that 2x squared to the other side. Now we're going to divide by -1. In my order, it comes out to be 2x squared minus 10. In your order, it would be -10 plus 2x squared. It does not matter. Now we square root both sides. In the answer blanks, there are 2 of them. We'll have the square root of 2x squared minus 10 and the negative square root of 2x squared minus 10. All right, we good? Now, there will be some of you who will say, oh, I don't have any math homework tonight because Mrs. Ford did it for me in class.